At its simplest, chemical engineering is the science of converting one thing to another. Consider a world without oil and gas or without electronics and plastics, for example. As a chemical engineer, you will quite literally be changing the world. People usually confuse chemical engineering with chemistry. However, chemists study the behavior and properties of materials in labs, but chemical engineers exploit this lab-scale product into finished products in industries, while keeping in mind the profitability every step of the way. Fertilizer. We all know that which one is more productive, plants provided with fertilizer or without it. Fertilizers are manufactured using Haber-Bosch process, which combines atmospheric nitrogen, which is usually very unreactive, with hydrogen gas, which comes from methane. High pressure and high temperature are required to solve the problem of unreactivity of nitrogen. Plastic. In the production of plastic, the raw materials used are fossil fuel-based chemicals like natural gas or petroleum. In here, nobody can question the role of chemical engineering in plastic production. Paper. Have you ever thought, even for 1 minute, how paper is made and why its color vary while using it in each and every aspect of your life, like currency, toilet tissue, writing paper, and so on? No worries, chemical engineers will gladly answer and also make it for you. In brief, the paper production's procedure starts first with chemical processing of cellulose fibers derived from wood and other sources in water. Secondly, draining the water. After that, pressing, and finally, drying. Color variation is due to the quality of raw material. Drugs and vaccines. You may wonder what's the contribution of chemical engineering in the production of drug. But actually, the equipment used in the production of drug, like reactor, mixer, the optimal condition required, like temperature, pressure, quality control, the amount of product, and many other tasks are performed under the provision of chemical engineering. Vaccines. Fundamental chemical and bioprocess engineering principles and tools will be key to developing and manufacturing vaccines and expanding the availability around the world.
Petrochemical. Chemical plants produce olefins by stream cracking of liquefied natural gas, and then olefins are used in making important industrial chemicals, plastic products, and synthetic rubber. Not only olefins, but also aromatics are produced by catalyst reform of naphtha and are used in producing synthetic detergent and dyes. Hydrogen fuel cell. Fuel cells convert the chemical energy in a fuel directly into electricity, like batteries. They can be used for stationary, mobile, or transportation. Hydrogen enters the fuel cell and is oxidized at the anode to form protons. The electrolyte material conducts ions, but not electrons, so electrons are forced into the external circuit. At the cathode, oxygen is reduced to water. Microchip. Microchip or integrated circuit are made of silicon, which has the surprising property of storing 3,355 pages of text on a device approximately the size of a dime or 10 cents US dollar. But the more surprising fact is that chemical engineers turns the silicon into a semiconductor chip, which has a tremendous contribution in manufacturing of microchip with a very careful and meticulous process. Aerospace. Chemical engineers covers all of the basics for air and space in depth, and is also tremendously useful in advanced space technologies, whether it be nanofabrication of materials for satellites, electrospray thruster systems, which are ionic liquid fuels, or membrane systems for purification of water or air and of Earth's life systems.